In this video, we're going to work through section 6 from the 2016 exam for Math 121. We have a scenario here where we have a vase sketched out, and it has square cross-section. So each of these elements here are equal sides, 90-degree angles. What we've been given is what is easier to measure, which would be a perimeter of these shapes as we go up from the bottom to the top of this vase. What we're asked to do then is use the trapezoidal rule to estimate the volume of the vase. And the fundamental element here is just making sure that you're actually calculating a volume. So what would make sense, or how we would interpret the trapezoidal rule here, is to find an area of this side and an area of this side. And once we have that area, then we would multiply by the height. That'll give us a third dimension. But how do we work with two areas at once? Well, we would take the average area times the height, and that would give you a good estimate of the volume of a slice. So the challenge here is to recognize what we need. We need volumes, and how to achieve that using the trapezoidal rule. The trapezoidal rule takes values at endpoints and averages them, and then multiplies by the distance between them, heights, widths, some distance like that. Once you've made that connection, then it's a simple matter of getting from the information provided, which is perimeters, to the areas. Well, how do we go from one of those to the other? I think the most natural thing is to move in stages. If we have the perimeter being 12, the side length is equal to the perimeter over 4. We take the entire perimeter and divide it evenly among the four sides. And so 16 over 4 is 4. 20 over 4 is 5, 4, and 5. So we can get the side lengths on each of these squares. And of course, once we have the side lengths, we can get the area, which is the side length all squared. So that'll be each of these elements squared. Notice the units now of area will be in centimeters squared. What we're going to do is take this size here, which is 9 square centimeters. We're going to take the 16 square centimeters here, and we're going to combine those and say, well, the average between on that general interval should be, say, halfway between 9 and 16. That'll be an ingredient for our total volume, which is, all right, our 9 plus our 16 over 2 times the distance between these two. That's a 5 centimeter jump. And if we check the units, this makes sense. We have centimeters squared times centimeters. That is definitely units of volume. And we just keep doing that for all the different sizes. We have 25 for the area next. Then it gets thinner again, so we have 16 and a 25. We just keep using the pairs 16 and 25. And 25 in the next 16. And last but not least, the 16 in the last 25. And every time the height that we're multiplying by is this distance from this slice to that slice, using the average area as the other two dimensions. This slice to this slice, it's always 5 centimeters for each of these slabs. At this point, you can either go through the calculations step by step, you can factor things, however you want to approach the calculation with you and your calculator and the paper. At the end of the day, though, you're going to end up with cubic centimeters and 370 of them by completing this calculation. And so that would be our estimate for the volume of this vase. And that's the end to question number 6, section 6.